Hi, it's Robin. Even back in the 8-bit era, lots of computer hobbyists were often trying to make their computer systems faster by upgrading various peripherals. The Commodore 64 had lots of software and accessories to speed up the disk drive, and even some to speed up the CPU, like this Super CPU accelerator that I've shown in other videos. So I was intrigued by this Commodore 64 cartridge that's labeled the SpeedCart 64. With that name, I thought it might be some sort of CPU accelerator, but in fact, it does the opposite. If you've ever wanted to make your Commodore 64 slower, then this is exactly what you need. It's a pretty bizarre looking thing, not particularly professional looking. On the top side, there's just a number of traces and solder joints, and something I've never seen on a Commodore cartridge before, a great big potentiometer. Looks more like something that would be on my bass guitar than on a Commodore cartridge. In fact, I even grabbed a volume knob off one of my basses, and it fits perfectly on there. But it's a bit heavy, and I'm kind of worried about the way this is connected here, and just the mechanical strain of putting extra weight on it. So I won't leave it on for this video, but it does fit perfectly. Now on the back side's a few more components, a capacitor, a diode, and one IC, a Signetics 74LS00N. It looks like a date code of 1989, so that gives me an idea of when this was made. Now we'll try to figure out how it works later, but first let's see what it does. It's not necessary, but I'll be using my cartridge port expander just so you can get a better view of it, and also so I can plug some other cartridges in later at the same time. So, power up the C64 and it behaves just like normal. And of course, we'll run the little 10 print program. And get that classic maze. So the only control that the SpeedCart has is this potentiometer. It's currently all the way clockwise. I'm going to turn it counterclockwise. Turn it. And suddenly the 10 print program has stopped. Now I'm just going to turn it slightly clockwise again. Ever so gently. And there we go. It's a very slow Commodore 64. The 10 print program's just crawling along here. And even kind of stuttering a little bit. So if I turn it counterclockwise, complete stop. And again, if I turn it clockwise, there it is, full speed again. It's actually very sensitive. You just have to find exactly the right spot there to get the slow speed. And if I turn it clockwise again, it'll go back to full speed. If I stop it and the cursor's flashing, this might give you another clue what's going on. So I've turned counterclockwise. Actually, the cursor is speeding up faster. And I ease back. There's a slower blink than normal. A very irregular flash. So let's try a few game cartridges with it. So we'll try GORF with it. Again, I've got the dial all the way clockwise. Now we'll turn it counterclockwise. And the game comes to a complete stop. And again, I'll ease to the right. Whoop. It is very touchy. There we go. So there's the game running in slow motion. And presumably this is the main appeal of a cartridge like this, is to slow down a game to the point where it becomes way easier for the player. It is pretty easy. There we are, back to normal speed. Another classic is Jupiter Lander. Of course, we could run disc-based games as well, but I don't have a disk drive hooked up today. It's just handy using these cartridges. Not a very good landing. Okay, that's normal speed. Let's try slowing it down here. Now turn it counterclockwise. And no effect. Well, the game's not slowing down at all. I've turned it all the way counterclockwise. Nothing there. Ooh. Out of sky. Okay, so we've had one that it works on, one with no effect. Let's try my well-worn copy of Jumpman Jr., one of my very favorite C64 games. Okay, we'll try playing at regular speed. One-player game, speed 3. Okay, it's playing just like normal with the dial clockwise. Alright, what happens if I turn down the speed? Turn it counterclockwise. Well, got all the way counterclockwise now, and no real visible effect except that that green line right above the score is flickering a lot more than normal. You see it down there? But the game at play actually seems all the same speed. Oh, did you see that? I can't pick up that bomb. So I'll turn it back clockwise, and now I can pick up the bomb okay. Let's get the last bomb. While it's climbing, I'm going to turn counterclockwise. There. Can't finish the level. So some games don't slow down, but there is still some glitchy effect, such as here in Jumpman Jr. Okay, here on my Easy Flash cartridge, I flashed a copy of Death Ride, Mountie Mick's Death Ride. A nice version here by Nostalgia. This is my favorite game about a Canadian Mountie. Okay, let's play normal with the control clockwise. So let's try slowing it down here. Oh. Okay. So if you turn it far enough, the game starts to glitch out. Really severely, but you still have a little bit of control over the player. Oh. Okay, here he goes. You can do these incredibly big jumps. The screen's totally glitching out. We can still sort of play it. Oh, God, jump! Jump! Oh. Okay, so yet another effect of this cartridge is slow down, but actually very, very buggy gameplay. Oh, there, it's really speeding up all of a sudden. Yeah, you can even cause the title screen music to play fast. So you see, sometimes when you turn it counterclockwise to supposedly slow down, some things will speed up. Like, there, the music is actually playing faster the more I supposedly slow down the system. 2 more games here. We'll try Bruce Lee 2. So here we go. I'll turn it counterclockwise. Oh, and we totally crashed the game. I'll try that one more time. So that's another effect, just totally crashing the game. Just try to turn it very carefully here. Oh, nope, totally crashed again. And finally, we'll try the Kung Fu Flash that I got from Rod at The Future Was 8-Bit, cartridge designed by Kim Jorgensen. And I've still got Wizard of War on here from when I did the Magic Voice episode a while ago. Okay, and here we go. So here's another one. I got all the way clockwise, turning counterclockwise. Okay, and this is another game that seems to work fairly well. In slow motion. Oh, but it's glitching out, isn't it? So, it's not working that well. Yeah, you can see different parts of the maze are distorting, or extra characters are forming. Pretty strange. Okay, so have you figured out what this cartridge is doing yet? Here's one more little program. So with this little program, we're just resetting the built-in clock. And if we run it, we're just printing out TI over and over again, which is the number of jiffies, that is 60ths of a second, since the timer was reset. So you see that we just hit 600, 700 jiffies, divide that by 60 to get the number of seconds. So here when we hit 1200, divide that by 60, that's 20 seconds that the machine's been running. So if I start to turn this counterclockwise to slow it down, watch the count there. You see how it's speeding up a bit? And now I went too far clockwise. Okay, there we go. Right, so I found that sweet spot that slowed down GORF and some of the games. And what's happening is that the TI count is exploding. It's just rocketing off, where we've got, say, every second roughly, we're getting 1,000 jiffies going by. There should normally be just 60. Now, the way the Commodore increases the jiffy count is that it sets an interrupt that fires 60 times a second, and each time it takes care of reading the keyboard, flashing the cursor, and incrementing the time clock, the jiffy clock, by 1. So the way this number's rocketing upwards, oh, there it was a little bit touchy again. The way the number is rocketing up indicates that what this card is really doing is firing extra interrupts. Many extra, like thousands of extra interrupts. And that's what's making the jiffy count climb like crazy. So if I turn it back clockwise, you see how now it's just counting up by ones again. Quickly, like 60 a second. And again, if I turn it counterclockwise, too far, it just freezes completely. But if I turn it back, there, it jumped all the way up to 300,000, over 320,000. So what's happening is this cartridge fires extra interrupts, so many that the main program slows right down. As we've seen, it only works on some programs. If they were programmed correctly, if they were programmed in a certain way, it's compatible with this. If not, it'll crash, or it might just ignore it altogether, or whatever. Now, there's very little online about this SpeedCart 64, but apparently there's a very similar product. I'm not sure if it's a complete clone, by a company called Rex in Germany, sometimes called Rex Slowdown or Slowdown 64 or Bremse 64. I don't know if I said that right, but basically it's the German word for brake, like to slow down. But B-R-E-A-K as well as B-R-A-K-E are both pretty appropriate for this. It breaks it one way or the other. And I don't know if this particular cartridge ever came with an enclosure, but that German Brake 64 does. Okay, and just to take a bit of a look at how this thing works at the hardware level. As I mentioned before, I'm no hardware expert, but this is a pretty simple circuit, and I made this diagram just to show how simple it is. Thanks to my son Peter, who's taking electrical engineering in college, and my friend Adrian Gonzalez, who's working on that Super Snapshot clone. They looked at this for me and helped with a couple little corrections. So for the components, the potentiometer is a B10K, so that means it gives variable resistance up to 10K. Now it's a type B, that means it gives a linear distribution. So it's actually not the same as what you'd find in most guitars, which give a logarithmic scale just because of how the ear perceives volume. If it was truly linear, then most of the volume would seem bunched at one end of the knob. So this one is linear and better for use in these sort of applications. So here on the expansion port connector, it's getting plus 5 volts DC from the cartridge port and sending it up to the IC. We'll look at the other side shortly. And here's ground on this side. So it's running through the single IC, which again is the 74LS, 5 volts and ground on these corner pins. The other 12 pins are groups of NANDs, that is, not ANDs, which you may know can be combined to make any other kind of logic gate. So it's got 4 NANDs available on it. You can actually see the ones on this side aren't used at all, and these remaining ones are tied together. So what's happening is that for the NAND, these two pins are tied together, and then the output is tied to the next logic gate. So what you actually have is just, that turns these NANDs just into a NOT, so they're just both inverters. And so I've shown that here on the circuit, that these two NANDs are essentially just turned into NOTs that will flip. So I showed this to a few of my other friends, and Chuck Hutchins probably described it best when he said, the gate inputs are tied together, effectively making them both simple inverters. Okay, and the two other components are this capacitor and this diode. And the capacitor is shown here, 1 microfarad, and the diode sits here, and you have the IRQ line, and the diode goes through here and comes out here on pin 4, which is the IRQ line, so it can generate an IRQ signal. And there's a few traces here that are completely unused, and I believe those are for adding a reset button. So we've got 5 volts DC going through here to ground, the potentiometer that can be turned to send a variable amount of voltage from 0 to 5 volts into this loop. Okay, my friend Jim Happel suggested this looks like a simple RC timer circuit, and Chuck Hutchins confirmed that yes, the resistor is the adjustable potentiometer, and that the capacitor charges and discharges on either side of the resistor. The top side of the capacitor gets pulled lower or higher while it's charging or discharging, changing the voltage just enough for the gate input to read high or low, but never actually ground or 5 volts. And that's why it's so touchy. You have to find the position of the potentiometer to get just enough voltage so that the gate inputs change state. So if this is high, this will be low, which will make this high, which will reverse bias this diode and apply 5 volts to the bottom side of this capacitor. Then that capacitor will charge up, which would pull this side low, which would then reverse the gates again. And every time that would alternate, this will generate an IRQ. Now I was thinking the diode was pointing the wrong way, but Jim Brain explained to me that the diode turns the push and pull output of the TTL into an open collector, because when the output is low, the current conducts from the weakly high IRQ line to the ground of the output, bringing the IRQ line low. But when it is high, the diode won't let the high value bleed over to the IRQ line on the 64. So actually, even though this is kind of like an output to the IRQ, but because 6502 architecture is normally high, it's actually the high signal comes through and allows it to go low, signaling the IRQ on the processor. So ultimately, you have a circuit here where, based on the potentiometer, you have IRQ always high, which means no extra interrupts are generated, or you have it always low, which means IRQs are continuously created, and as soon as the 6502 is done servicing it, it immediately fires another one. Or if you get the voltage just right, this becomes an oscillator which will fire off periodic IRQs that will make the Commodore 64 more busy than normal. Again, depending on how the software was written. Okay, thanks to those guys for helping me figure this out. If I still got it wrong, it's my fault, not theirs. So check the comments in case there's any further clarification about how this circuit works. Potential improvements that were suggested are to use a 555 timer, and the guys were actually wondering why this particular oscillator design was used instead of something like a 555 timer. Perhaps this was just cheaper, I don't know. Another option would be to also allow, optionally, NMIs to be generated, as that may slow down some software without causing the problems that frequent IRQs generate. Again, not as a primary way of working the circuit, but as an option, and it may allow more software compatibility if you could choose between IRQ, NMI, and maybe even both. And one other way of designing this would be to have it calling the DMA line instead, which may be even more compatible, but would require a more complicated circuit. In case it wasn't clear, SpeedCart 64 does not affect the Commodore 64's system bus speed or clock speed at all. The computer continues to run at the same 1 megahertz, give or take, that it always does. This cartridge just fires off spurious extra interrupts that may or may not cause the computer to become so busy that it can't do its regular tasks as quick as it should, or in some cases at all. But as we saw, it's actually not a particularly good design. Perhaps somebody with more hardware skill than me will get inspired and make their own version of this cartridge that does work better. That could be interesting to see. Okay, thanks to my patrons for their support. If you haven't, please consider subscribing. Thanks for watching, and we'll talk to you next time.